Stop vent sweating. I don't really even love this first point. It's not that it's not true, but the main way to stop vent sweating is to keep the relative humidity in the space controlled. Right, so when you are getting 60% or above in the space, that's generally when you get vent sweating. But source control is a big factor too. So clients who leave doors open, one of the worst jobs I ever did, where I chased it for months and months and months and months. I was doing all kinds of crazy stuff, trying to get it figured out. I did all the wrong things. I actually have two stories like this. I was talking to the senior tech. I was like, man, I cannot figure this house out. It's one room. It's up in the peak, a vent up in the peak of the living area, and I just cannot keep this vent from sweating. I tried installing a plastic vent. I sealed all around it. I did all kinds of stuff. I put some sort of coating on the vent that was supposed to reject water. It was like Rain-X. Go ahead, Fabian.
There's a question. You guys have a device that actually tells the humidity of an area, the thermostat.
Other than the thermostat? Sure, yeah, there's a lot of indoor air quality monitors, like tabletop monitors, like IQ Air and others that can do that. I've messed with one called Foobot for a while. There's a lot of Laser Egg is another good one. There's a company called Haven, which is an in-duct. It does RH actually in the return duct, and it will tell you PM 2.5 and VOCs and all that kind of stuff. And then there's devices called Hobo that you can leave on site and measure it over time and then come back and read it. So yeah, there's a lot of different types of devices like that. And I would definitely advise having something that you can deploy in cases where you're going to be doing a high dollar project, where the customer's already said, yeah, okay, I'm okay with the budget. And now we need to figure out the plan and we need to test out to make sure it worked. Those are the sorts of strategies that would work there.
Hold on, can you just finish your story?
Yes, I will finish my story. Yes, okay, so in this peak that I was trying to keep from sweating, I just trying everything, and so I went back to the shop. This is my previous company I worked for. Senior tech said, client have a pool? Yeah, they have a pool. How did you know? He's like, they're keeping the doors open. I'm like, no, they're not. They would not keep the doors open and then hold me responsible. These people have been yelling at me. They've been calling me every name of the book. No way. He's like, yeah, they're keeping the door open during the day. So I go back. I'm like, so do you ever keep this door open? I'm like, oh yeah, when the grandkids are playing, yeah, I keep it open. And source control is huge, right? Where is the water coming from? And openings in the building, like an open door or an open window, are massive. And people don't understand. They're like, yeah, but I turn the AC back on, I shut the doors, it gets back to temperature, why is it sweating? Because that's not how it works with latent. It takes forever to get it out of everything, and there's nothing you're gonna do to solve that problem if they're just gonna keep the doors and windows open, that kind of thing. So you have to, you gotta kind of know your client a little bit in that regard. I have another story like that, but I'm not going to tell you. It's the same basic idea that client behavior and source control is huge, and that's where bath fans, kitchen exhaust, open doors, open windows, that sort of thing is huge. The next layer is thinking about where the entry points are to the space. Where are the straws that can suck in moisture? And some of the most common ones are can lights. And so when you have houses that are really bad inside, having issues, walk around the building and look for straws, look for openings. Where is moisture making it in? Like I said, ductless systems where they just make big holes through the wall and they barely seal it, right? If you have can lights that are open cans, not sealed cans, with the old school light bulbs, they should pull them suckers out and put sealed LEDs in, like right now. That's a huge factor. Around the boots, if you pull the grill off and there's a jaggedy edge around where the boot sits in the ceiling, seal that up. You can seal it from the top with mastic. You can seal it on the other side with caulk. I don't care how you do it. Just get that sealed. That you can make good money doing that. Go through the whole house, seal all these. It's going to be XYZ amount of dollars. It's not a big job to do, and it can make a really big difference. And again, it's death by 1,000 cuts. It's not like you just seal that one. See, this is a mistake people make. It's like, well, that one's the worst one, so I'm going to go seal that one. No, seal all of them. and deal with the bath fans, and talk to them about the kitchen exhaust, and talk to them about keeping the doors open, and look at all the can lights and replace them with LED cans with gaskets on them. You do all those things, that makes a difference. If you just seal one, even if it's the worst one, you're not solving the overall problem, because the overall problem is all the straws that are bringing moisture into the space. That make sense? Any other questions about that? Go ahead.
All right, question. Example, why the group sweat? Everything's sealed, no leak, no transfer heat, nothing, right? And because you have 4 airflow, it's cool. When you increase the airflow, it stops.
Sometimes that is the case. But again, it's going to be localized. So if you increase the airflow of the whole system, so say you go from 350 CFM to 400 CFM on the system, sometimes you temporarily will see, oh, okay, it stopped sweating because you did make the air a little warmer. So you dealt with the surface temperature part of the equation. Remember what I talked about? Dew point of the surface temperature. So colder surface temperatures tend to condensate. But what's the other side? What is the dew point of the air around it, right? So when you increase airflow, what do? You increase the surface temperature, right? So that increased. But what did you do to the dew point in the space? You increased it. It got more humid in the space. Why? Because now the air conditioner is not removing as much moisture from the space. So there's been a lot of cases that I've done exactly that. I've gone there, ducts are sweating, air's too cold. Okay, here's what we do. Increase airflow. I was so stupid when I first started, I would take 3-ton systems and set them up to 5 tons. Because I didn't understand anything. I was like, hey, just give it as much air as you possibly can. Hey, look, everything stopped sweating. Great, you're great, great. Sign the invoice. 2 days later, everything's raining in the house, right? Because now the system is no longer pulling moisture at all, right? So temporarily, it warms up the vent. Does that make sense what I'm saying? Yeah. So you have to think about the overall condition of the house and its relative humidity, and then the localized condition of the vent. And a lot of times, you'll see it a lot in big cathedral ceilings where they're really high up. And again, that's that whole thing with moisture like we talked about. Water vapor is lighter than air. So it's going to try to make its way up there. Sometimes even doing silly things like putting a return up nearer the peak of the ceiling can help. Because now at least you're getting some of that moisture pulled off that roof peak. There are strategies you can employ that can be helpful. Sometimes it can be as stupid as, like, hey, would you like a ceiling fan in this room anyway? Yeah, okay, I've always wanted something. Fine, put it up there close to that peak and get the air at least moving down away from it. So that way because you're not really doing anything other than just kind of mixing that more humid air off the roof peak. But what's even better is make it drier in the whole house, right? Anything that makes it drier in the whole house is important. And what do we do with equipment that makes it drier in the whole house? This is a quiz. What do you do with the air conditioner to make it drier in the whole house? Go ahead, Simon. You have a colder evaporator coil, and you have longer runtime. That's all. That's all an air conditioner can do. Colder evaporator coil, longer runtime. So people will be like, but. Anybody thinking of any buts?
Yeah.
Go ahead.
What about the fan speed?
What about?
Fan speed.
Well, fan speed results in colder or warmer evaporator temperature, right? If we increase fan speed, what happens to the evaporator temperature? Goes up. So what happens to the ability to dehumidify the whole house? Goes down, right? So if we drop fan speed, that makes a colder coil. That's what that does, right? And so people say, but what about multi-stage equipment? Multi-stage equipment solves that problem, right? Inverters, that solves that problem. What does inverters do? Inverters can run longer. Why? Because rather than shutting off, they stage down. Like I said, runtime and coil temperature. That's it. Runtime and coil temperature. You want it to never go off, and you want the coil to be cold, okay? Here's where it gets really, really crappy, okay, because I've seen this in the house we're staying in. Clearly, they weren't happy with how the air conditioner was working, so they started throwing ductless systems at it. Ductless system here, ductless system there. Like I said, Oprah, everybody gets a ductless system, right? Who thinks that ductless systems are really good at dehumidifying? Raise your hand. Who thinks ductless systems are really good at, hey, you guys know better. Why aren't they good at dehumidifying? They don't because the Japanese really don't believe in the existence of humidity, is why. What they do is they say, because remember we talked about compression ratio? What's the best way to get efficiency out of an air conditioner, to get high SEER ratings? to have low compression ratio. And compression ratio is low head pressure and high suction pressure. That's low compression ratio, right? High suction pressure, what's another name for high suction pressure? High evaporator temperature. You guys are all falling asleep on me now. You've been doing so good. And I'm even excited. This is my favorite topic. High evaporator temperature, right? That's opposite of good dehumidification. So a system that's running efficiently on energy is running crappy on dehumidification. And what do the Japanese care about? They care about getting really high SEER ratings because that's what people buy them on. So run away from 30 SEER ductless system, run away, run away. Bad dehumidification. If you look at the stats, the actual dehumidifying capabilities of those systems, sometimes they are absolutely terrible. Sensible heat ratios, which we're not talking about here, but terrible, terrible. So more and more manufacturers like Daikin and Atmosphera with their Atmosphera line or whatever, they're starting to catch on that the way to make ductless systems work really well and be good dehumidifiers is just peg that coil temperature as low as you can get it. So peg it to 40 degrees or lower, just run it that way, and now when it stages up and stages down, it just runs a cold coil. So what does that mean? Longer run times, colder evaporator coil. Not long run times with warm evaporator coil, which is what they've been doing. So it doesn't matter if they run all the time. If the evap coil is warm, they're not dehumidifying, they stink. They're horrible, they make it worse. You put a dehum in, the moisture problem gets worse in the house. Put a ductless in, the moisture problem gets worse in the house. Put a dehum in, so this is what a dehu does. This is the thing that a lot of people miss. It's not just that it pulls out moisture, but if you put your hand in front of a dehumidifier, what does it blow out? Hot air, warmer air, right? So it's hot. So it adds to the load, which increases the runtime. Like this is why, and I don't know that Evolution still has this, but Carrier for the longest time had the option where you could actually do reheat with electric heat strips on these systems in order to help reduce humidity. You could literally run electric heat to reheat to increase runtime.
I was just going to ask you that if you can use a heater.
Yeah, it's just way inefficient. Like it's just horribly inefficient. Again, about 3 times less efficient, a third as efficient as using a dehu to do the same job. Go ahead, Matt. You were going to say something?
Yeah, I had a call a couple weeks ago that was all related to high relative humidity, old duct sweating or vent sweating, and like we were saying, source control. So they had an inline blower bringing in fresh air constantly.
Yeah.
So they were just always bringing fresh air, and then they had the fan set to on because they had.
Yeah, that's a toxic. Yeah.
They had a portable dehumidifier like set up, and then under the main return, they were trying to suck the dehumidified air like throughout the house.
Yeah. So all of the wrong ways. Right.
Yeah,
Right. Everything wrong.
And it was like a 3.5 ton unit with a 5 ton furnace, so the airflow was set wrong too. So got it all set up. Talked to them a few days later. I think their relative humidity was like 75% or something.
Yeah.
And a few days later, it was like 50.
Right.
So yeah, like tracking down all the different things. And I was just like, we're just gonna try this, you know. Let's just try a couple things here.
Yeah.
And you know, and we'll come back and see if we need some of these other solutions.
Yep.
So maybe what were they trying to achieve with that fresh air emission? Maybe to get rid of stained air or
So
something.
it's
Starts putting in more humidity, right?
Yeah, it's code in the U.S. Any new house has to have fresh air. So
If it's sealed to a certain level, yeah.
100%?
100%. What do you mean? 100% of new houses? It's no. Like there's various strategies you can utilize, but again, you get a lot of people who are real. After COVID, there was all this talk about ventilation being the solution to so many problems, and it is. Ventilation is great, unless you live in a super humid climate where you probably cause more problems than you solve when you bring in a bunch of outdoor air. You have to really control it, and you have to really limit it, right? So if you're going to bring in continuous in a market like this, you should probably be bringing in like 30 CFM, something like that, 40 CFM, a very minimal amount, not like 100, 200 CFM. That's not going to be unmanageable. You're not going to be able to manage that through your typical equipment. And again, generally speaking, you don't need to bring in continuous. If you can do it the way you want to do it, then the way to do it is to do it based on demand. Run it through something like a Haven or some other controller that you're only bringing it in when there's a reason to bring it in, when CO2 levels are elevated or when VOCs are elevated. Otherwise, who cares? right? That's why you bring it in, is to deal with contamination inside the space. Like if you're at work all day and nobody's in the house, why do you need to bring in outdoor air? Just so that you can remove the humidity from it. That's a silly thing, right?
Yeah, I do mine. I have mine on a timer. I don't have a monitoring CO2 and VOCs, but I do monitor CO2 VOCs, and I make adjustments. So if I see that my CO2 is going above 1,000, I keep it around 800 below. Right?
Yep.
So if it's consistently, when I'm away from work and there's no one person there, I adjust it so that it's about 800 or below.
Yep.
Right? So if I see it going above there's more people in the house, I just make slight adjustments to the timer.
Yep.
So that I'm maintaining, I see it doing a VOC target.
Right. And that's the issue with bringing in outdoor air at all.
Is there a CO2 as well?
We're the main source, so we don't have any combustion. So people that is really,
Yeah.
for us, are the drive and pets too.
Yep.
And we got sweat.
Yeah, and that's it. That's even PM 2.5. That's more about filtration, right? That's more about having a good filter in there. So, so chemicals, that's your VOCs, and CO2 is people breathing. Fun fact: if you ever notice after you have like like a big party, everybody gets tired after dinner. Like, oh, they're so tired. And people say like, oh, it's because you're full. Well, that is one reason. But the other reason is if you track CO2, which I've done at my house, which is kind of fun, I'll get 2,500 level of CO2 in my house after like Thanksgiving dinner or whatever, and that can make you tired. Like that can make you sleepy. So a lot of times when you have big groups in your house, that may be something to do with it, is that the CO2 levels are elevated. But again, the point is that a lot of times we're trying to kill a fly with a hammer, right? The fly is elevated CO2 and VOCs, and we go bang, and we like destroy everything by bringing in a bunch of outdoor air, especially in a humid climate. If you live in a place where the air is dry and it's nice and comfy, well then great. I don't know why you have air conditioning at all then. Return and supply air duct leakage. I've already talked a lot about this, so I'm not going to keep talking about it, but it's just bad. It causes moisture problems, and it's indirect, the reason why it does. It depressurizes or pressurizes the space, which results in moisture drivers pulling it in. You cannot put air out of the space without bringing in the same amount from outside. And so when your ducts leak, it causes problems. And that's where I would really advise on houses that are a real issue with moisture, and you've already kind of done the more simple things, really look at duct leakage. And a lot of that can be visual inspection. I'm not the kind of guy who says you need to do a duct blaster on every install or anything like that. I don't think that's necessary. Most of it is just if you're going to do an install, and especially if you know that there already is a moisture problem, if you're doing a sales call and you can see that it's part of it, really make that duct side of things part of it. And also think about that return. If it's sitting on a platform, like what's sealing that platform underneath? What's keeping it from pulling in air from wall cavities and all that stuff? Just think that stuff through. That can cause a big challenge.
Do you ever use a Diagnostic that sells,
Sure.
This is really leaky, you can say so and so.
Yeah.
And then you do it with yours, and you say, look, you say this is reduce your leakage significantly.
Yeah, for sure.
And you show us, do you ever do that?
Yeah, we have. And again, that's knowing your client. Like, I think our market's very similar to yours. We have a mix of very wealthy clients. We have a mix of people who are going to be willing to pay for that stuff, and you have a mix of people who aren't in the position where that's going to make sense. And a lot of it's just a quick conversation. Hey, do you really want to solve this problem? Okay, the right way is to do some further troubleshooting here. Do you want to take that route? Because that's going to cost some money, or do you want to just go to these solutions that are very likely to provide these outcomes? And again, as long as you understand what the risks are, and you're making that judgment call along with the client's consent. But ideally, every house we go into, we'd have a blower door on one shoulder and a duct blaster on another and a true flow grid. But I mean, come on, like there is a point where it gets a little ridiculous, where it's not realistic. But that is something I would encourage you to do. There are very few contractors who have successfully deployed building performance as a whole package. You guys are in a really good position because you don't need a whole package. You just need to solve a couple problems that people consistently have. And the biggest one is moisture issues, because it's so apparent to them, right? I can smell it, I can see it, it's there. There's very few things in our homes that are that apparent, and we have that advantage. And that's where just knowing that, like, hey, underneath platforms or in attics, if you know the whole issue with the train air handlers leaking and all that, these are common things that we come up with, and we can solve these problems by planning a little bit better. Humid climate checklist. Think twice before removing radiant. Okay, what that means is not radiant barrier, so I should have been more clear when I wrote radiant. Radiant loads. So like sunlight coming into a house, it's good. We like sunlight. Sunlight drives up the temperature of the home inside, which does what to runtime? Increases runtime. But it doesn't bring any moisture with it. Also, sunlight is good, right? Sunlight's good for you. It's healthy, like generally speaking. So when we get really fixated with close your blinds, make this place a cave, right? You're actually going to be more likely to grow mushrooms in the house. And by that I mean children who play video games too much. But you do want to remove all uncontrolled convective gains. So we talked about, convection, conduction, radiation. I talked about that with the apprentices. You do want to remove uncontrolled convective gains, which means that leaks in, leaks out, duct leaks in the attic, all that stuff. You want to reduce that. And a lot of people will say, like, wow, but the house is unhealthy if you don't look. For most of us, we open the doors enough and we're in and out enough that there's actually a pretty good amount of outdoor air coming in. My house, heaven's sake, I do not need outdoor air brought into my house with all those children going in and out and the dryer running and all the other stuff that's going on, right? Because that's another thing. Even a dryer is discharging air out and it's drawing air in. That's another big one.
I had a case where we were in the same situation. There was customers complaining it's humid, it's not coming down to temp, and stuff sweating. And we did a lot of tests on the equipment, and before they had some big supply duct leakage. So I went around with a flow hood and checked to make sure there's no leakage and all this checking. And when I was there, they were running the dryer. I thought, okay, yeah, I can't really get good data, but it's just one of those things. I told them next time, I'll do it. I came back again, did some more testing. It's still humid, And the third time I came back, they dry clothes again. So I said, how often do you guys dry clothes? This time we've been here multiple times. He said, probably every day. And I said, every day they're drying clothes, and every single day, twice a day, they're mopping. Mm-hmm. Right? So I told them that's why you got problems keeping up, and why you got high humidity. Because you're changing out all of the house air every single time you run the dryer.
Yep. And it's not that they can't solve that problem. If they want to live that way, more power to them, but they're going to have a lot of supplementary dehumidification and probably upsized air conditioning. Because you can do upsized air conditioning as long as you upsize ductwork, and you can upsize and have a little extra load so long as you have a dehumidifier that helps fill those gaps. You're going to spend a heck of a lot of money on equipment and a lot on your power bills if that's how you want to live, but that's your choice, right? People can do that if they want, but to your point, dryers are bad. Not only that, but dryers that aren't discharging outside. Have you ever seen dryers discharging in attics? I mean, that's terrible for fire hazard, but it's also a lot of moisture. Dryers that are leaking around, the dryer vent's half off. That is a lot of moisture getting dumped into the house, a lot. And that's what I'm talking about. Keep your eyes open for that source control.
In Ontario, we discharge the dryer into the laundry room.
Really?
As long as it's not natural gas. Yeah, it comes with a snorkel kit and a little discharge on the top of the box.
Is it dry in Ontario?
Just feels very dry.
Well, then there you go. So you're not that worried about it, yeah.
Yeah, and I think for me, coming from a cool climate, I've never experienced 75 degrees so many different ways, right? You go to one house at 75 and you're dying, and you go into another at 70, 78, you feel great.
Feels great, right?
Yeah,
Right.
very different.
Excess latent capacity in your equipment is good. If you choose equipment, so again, this goes down to sizing. If you start looking at sensible heat ratios, all that stuff, for those of you who are choosing and selecting equipment. Choosing equipment that has excess latent capacity in your design, that's good. Excess sensible capacity, bad. You don't want oversized equipment just for the sake of oversizing. You want to have extra ability to remove moisture. Design the outdoor air system completely. If you're going to do an outdoor air system, design it. How much air do you want to bring in and how often? And what are the controls and all that stuff? You cannot just send a technician out, hey, outdoor air vent, bring in some outdoor air. No. Think it through, design it. Good, dew point of surfaces above the dew point of the air. That's what we want. We want surfaces to be warmer than the dew point of the air. Anytime you're like, why is this sweating? Because it's colder than the dew point of the air around it. Full stop, that's the whole reason, always. So what are your choices? You can warm it up, or you can decrease the dew point of the air around it. Those are the only two things you can do, and that's what you want to think about how to accomplish. Design for ducts and drains. This is a general concept, which is more about, because this originally I created for builders. It's like, hey, how are you going to drain this thing? Think about where you're going to run ducts, because when you don't design for ducts and drains, you run into a lot more moisture issues. Design exhaust ventilation with makeup air, which means that ideally when you have really big kitchen exhaust, you should have makeup air that's right there in that same system. That's what they do in kitchens, right? They bring in makeup air, outdoor air, right by the exhaust so it all stays right there. It's not going everywhere else with the outdoor air. It's balancing it there. Redundant condensate protection, we talked about that. I think we've covered that plenty. Make sure the controls are really, really clear, which means that those of you who are selling anything relating to dehumidifiers or complicated communicating systems and all that, make sure that the installers are really clear on what is expected in the setup. How do these get, because it's not just a matter of plop it in and walk away. Like, what do we leave it set at when we leave? Like, how do we duct it in? All those things have to be designed.
Sorry. Going back to number 6, let me interrupt. Did you guys design makeup air systems? You guys
we work with a company called Captive Air right in and they actually do designs anytime you have these more complicated, bigger systems. Again, we mostly only do this in commercial, but in Florida, anytime you have an exhaust that's more than 400 CFM by code, you have to have a makeup air system as part of it. Now, do they always do that? No, they don't. But I use that in order to tell people, hey, don't put this gigantic hood in here. Put a smaller one in, so that way you don't have to deal with this.
I got a problem in my house, but I got an adjustable. I got an outdoor motor, and I can turn the dial into my hood and adjust it. But I don't know. The best way is to bring in makeup air, especially if you're using. I got a big 8-inch hole. Can't drill another 8-inch hole.
Right.
I can, but
No, right. It's not an easy thing to do. You can do concentric. I mean, they make concentric systems that you can do. Yeah, it has to be a designed thing, right? And again, we're mostly talking about RPHs here, rich people's houses. If they're going to spend the money to put this giant hood in, design it with makeup air as part of it. Put system vents in attics, access in some places that aren't insane, again, for builders. This is a big thing, especially if you're putting dehumidifiers in. Like, you can't just put it in there and leave it. You have to have a conversation about the maintenance. This has to be part of the maintenance plan now. We got to clean the drain, we got to change the filter, got to check it out, all that stuff. And it's actually an opportunity for you to make money long term. But you can't just not think about that, because the client's going to get ticked if later on when it's time for their next maintenance, it's like, oh yeah, it's an additional XYZ for your dehu. It's like, nobody told me that when I bought the thing. That has to be part of the conversation. Let's talk about signs of oversizing, because again, like we talked about, actually, let's do it as a quiz. What are the 2 ways that you make the system remove the maximum humidity that it can? Cold coil, long run time. Cold coil, long run time. That's it. So when we think about oversized systems, a lot of, and again, I want to tell a story here, and some of you may relate to this. When variable speed blowers first started coming out and salespeople got a hold of them, they would go tell clients, guess what, good news. You don't have to worry about undersized ductwork anymore. You don't have to worry about humidity anymore. These systems are amazing. They have a dehumidify mode, and they can deal with bad ductwork. And then we put them in, and the motors started burning up, and they didn't do any better with removing humidity. In fact, some systems had worse humidity. And then they're like, crap, that didn't work. Then multi-stage equipment came out, and they said, good news, everybody. You don't have to worry about undersized ductwork anymore. You don't have to worry about humidity. The problem is solved. Crap, that didn't work. Then inverter-driven systems come out. Good news, everybody. You don't have to worry about it. You don't have to worry about system sizing, and that didn't work. Then ductless systems became popular. Good news, everybody. Okay, here's the point. It's not good news. In fact, many cases, the old crappy units we pull out, okay, the really, really crappy reams and pieces of junk that look like trash, they are amazing at dehumidifying.
And that's why a lot of times we have customers, but my older system that was there 10 years didn't sweat.
Right.
Why is the new one sweating?
Right. And so, but think about it, here's why. Imagine you have this old 3-ton ream with a dirty evaporator coil. It's crappy, it's got a dirty blower wheel on it. It's not working that well anymore. The compressor's not pumping as well as it used to. Okay? It's just not producing the capacity it used to produce. What's the coil temperature on that dirty, crappy old ream? It's low. It's not working very well. It's not working as well as it used to. So what's the runtime doing? It's doing long runtime. Hey, there we go. You should save that and put it in another client's house. You've got a great dehumidifier in your hands. Right? So again, it's important that we know that when we're communicating with the client, that's probably not going to dehumidify better. The new system that you put in, that inverter, high-end piece of equipment, probably isn't going to dehumidify that much better. Now, a really good one that can turn down to a really low operational percentage, you might actually do a little better, right? But don't think that you're going to do a lot better than that old crappy ream. You might, but you can't bet on it. And so when you sell it that way, you're going to make a mistake and you're going to run into some people where their problem actually does get worse. And a lot of times, because I remember when this first started happening, the owner of the old company I worked for, he'd be like, and he was a cusser, so he'd be like, well, bull, blankety blank, no way that happened. These are the best dehumidifying systems on the world. That client's stupid. You know, we had all this blaming the client. And I was out there like, yeah, I don't know. Like, it does have a mold problem now, and it didn't before, and I didn't know why. And so what I'm going to encourage you to do is, first of all, right sizing. Make sure that you're not oversizing equipment. A lot of times, if you can deal with the envelope, you can deal with the attic, you can deal with insulation, you can deal with some other things, you may be able to go down a little bit in size. And if you can, that's a win for multiple reasons. Because now the ductwork that was kind of sketchy now actually is good, right? So because you're trying to push less air through it. Now where you may have had shorter run times and short cycling, now you may be getting a little longer run times. So downsizing equipment, right sizing equipment is a really key point to getting better efficiency out of the equipment, getting better capacity consistently, meaning you're actually providing what you told the client you would get. Whereas if you put a 4-ton in and you have it on bad ductwork with high static pressure, you're probably not even getting 4 tons of air. If you put 3 tons in, you're going to actually get what the client paid for and at a lesser price, because you're going to pay a little less for a 3-ton than a 4-ton, right? Go ahead.
Yeah, so just to talk that she mentioned, so customers actually losing motors. She had changed 3 motors in 1 year period. So when I checked the static, it was okay. However, the returns were linear. Those aren't meant to be returns.
Right.
But what the guys usually do would take out the veins.
Right.
But in this case, it was delivered. And just by taking it out, it solved the issue and solves the humidity issue also.
Yeah.
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 You got more here.
Circulating back, yeah. Yeah, it can, yeah. And again, like sometimes you're right on the edge where it's like you're just a little change can make all the difference. And that's why I say, like, and in your sales process, once you open your eyes, and it's this wide, narrow, wide thing like I talked about, once you have a wide open view, a lot of times you can be like, all right, we're going to do that. We're going to replace these cans with sealed LED cans. We're going to seal around the boots. Okay, yeah, your bath fans, I would suggest putting in humidity sensing Panasonic bath fans. Hey, you've got this kitchen exhaust. Don't run that on high speed. That's an issue. You're kind of going around and you're just identifying all these things. Oh, and by the way, if we insulate the attic a little bit better, we can because insulating the attic is fine. I want to be clear. Insulating the attic, I hope you didn't hear that I said that's bad, because that's not bad. Insulating the attic, if you can get smaller equipment in it, by doing that is a really big win. Right? If you go to an old house and it's like, all right, and even if you're kind of doing it, I don't know how accurate you guys do your loads. I don't even really care that much. You know your market. But if you go to a house, it's like you kind of know it's oversized, right? But it's like then you want to go in with an inverter system. So who does sales here? Who does like a little bit of sales? Okay. If you want to go back in with an inverter system, you know inverter systems are full tons only. And a lot of times we're like, okay, we'll go to the higher ton. Try to go to the lower ton. Like try to make that happen. And sometimes by doing these small things, because all those little things that I just mentioned, those are all load reducers. Those are all cutting your load a little bit. And it's reducing your latent load, which is win-win. Right? So if you can do things that cut latent load and you can get the client to do that as part of the package, that really can help. And it also demonstrates a differentiator. It's like that's something nobody else is going to be talking about when you're in that sales process. So just 1,000 little cuts, reducing all that. Then you do some attic insulation or whatever, something like that that's a significant one. You can go down a ton or half a ton. Now all of a sudden your ductwork works better as well on top of it. Now you've really accomplished a lot there. And again, this is what I always say, like people who are super big into really complicated manual J's and all that. Look, a manual J is a guess at best, right? Because there's all kinds of stuff you put into a manual J, a load calculation, that you don't know. Like you don't really know the insulation in those walls. You're taking a shot at it, right? You don't really know the tightness of the house. You're taking a shot at it. And so it's good to have done it so that way you kind of know what to expect, but ultimately you're going to go on what you know about your market and how these houses are built. You're going to know like, hey, this was built in such and such a year, so therefore.
I do have a question. You mentioned yesterday, kind of early on, that a sealed attic could cause premature leak in an evaporator coil. What's the theory behind that?
The theory is that, especially with open cell foam, if it's improperly applied, it can off-gas some pretty caustic chemicals, which are bad for the occupant, but also can collect on the evaporator coils and cause them to leak. That's why I'm a fan of closed cell foam. It's much less likely. I've never run into a closed cell house where that's been the issue. People push open cell because it has a better R value. But that's not nearly as important to me as actually sealing everything. If you're going to seal an attic, I want the foam that's going to do the best job of sealing, and you get the benefit of it being structural, like it actually holds everything together then. And in a hurricane market, to me, that should be a pretty, especially on higher end houses, that should be kind of a no-brainer. It's expensive, but it's like, hey, this really helps beef up your roof system and all this. And I mean, you see everybody with these high dollar hurricane shutters that they install. It's the same sort of basic idea there. Sorry, that was a side note, but.
No, we have customers that have had their coils changed every year since we did the install. Three coils in 3 years.
I want to stress that there's a lot of chemicals in the air. There's a lot that can cause accelerate corrosion. It can do, but under normal circumstances, everything will it'll still off gas. But if you're having a case where the spray foam is off gas to that extent, you have a problem with them. And they probably have other issues. Like they're probably getting dizzy. They probably got headaches.
They can probably smell it. That's the main thing. Like in every case where it's bad enough that it is that we really strongly suspect that it is what's causing the coils to leak, when you walk in as a fresh observer, you can like smell that little bit of chemical. The nose is by far the best wide range VOC sensor on Earth. Like we can smell almost everything. Correction, the nose of a woman is the best broad range VOC sensor on Earth.
It's actually true.
No, it is actually true. There is a woman in England who can smell multiple diseases, provably, absolutely provably, before any other test can detect it. There's a case where she did a double blind with somebody who had Lou Gehrig's disease, I think, where she said, yeah, this person has Lou Gehrig's disease. And they said, no, actually they don't. And then 6 months later, it ended up that they had Lou Gehrig's disease. Like, it was how extreme it was. Like, she's crazy. And so it is a really true thing. And then you see, dogs are trained that way too. Like, there's a lot of animals. Not that I'm comparing the two. That sounded terrible. Jeez. How embarrassing. That was awful. So the point is that when you walk into a space, or if somebody says, man, it smells funny, it probably does. And it probably is some sort of a VOC. But here's what I would say to that. If you have a space where coils are failing more than once, go ahead and put some sort of VOC sensor, or at least suggest that the client get one. You can do something like I said, Haven, but even a tabletop will probably give you a pretty good indication.
We actually have done that multiple times, right? Went in and we have problems, and I went in and I tested the levels, and they're always high. Anywhere it doesn't do any ventilation is always pretty much.
High on VOCs or high on CO2? Or both?
VOCs especially, but CO2 too.
Okay.
Right? Depends on how many people in the space. Some of these people with massive houses and people.
Yeah.
Okay, CO2 is not high, but VOCs is like almost always high. Mm-hmm. Unless they're, just dried clothes or coming in outside all day long.
Yeah.
Something crazy like that. But under normal conditions, most places are really high.
Yeah.
All right?
Well, this one too sits above the garage in a guest house.
How old is it?
How old would that house be, Vic? It's Mike Guitards. 15, 12 years old. Mike Gotthart's place where he has the leaking coils every year? How old would that place be, the guest house? Maybe it's not that old actually, the guest house.
So it's not just so inappropriate, improperly applied foam is one, but like remember Chinese drywall? Did that hit here? Where there was this Chinese drywall that had all these chemicals in it, and it would eat up everything in the house. But here's the thing. Here's the way that as leadership I want you to start thinking. Don't trust anybody about this stuff because they're all idiots. Like they don't know and they just tell you that it's fine. They always tell you it's fine. Oh no, it's fine. It's not. Oh no, it's not the drywall that's doing it. Oh no, it's not. It's not this, it's not that. They don't know. And so it could be anything. It could be the paint. It could be anything going on in that house that's unique. And so you got to kind of be an investigator. Like, what is unique about this house? What materials were used in this house that it could be? Because in Chinese drywall, the only reason that they found out is because it was so bad, right? It was so extreme that in 6 months, copper pipes were corroding in half, right? So that's how you knew so quickly that you were able to catch it. If it's not that bad, who's to say, right? They're just going to blame, they're always going to blame the other guy. They're always going to point fingers. And so when you run into cases like that, I would do that sort of monitoring, but then you got to, as quickly as possible, put that back on the client. Like, and I don't mean that's like, I hate blame shifting, but it is not. If you have a coil that's leaking every year like that, it's not the coil, right? It's not. Unless it's some weird unit that just like is abnormal in some way. But coil leakage is an issue, but it ain't that kind of an issue, right? And now again, back in the day when coils were made and the walls were that thick, the copper, yeah, you would get away with a lot. Nowadays, they're not. They're very, very thin, and they are going to be more likely to leak. But we do need to say, hey, there's a condition in this home. We almost assuredly, there's some sort of material in this home that's creating a gas that's attacking this coil, and we have a hard time really knowing what it is. You can do things like phenolic coat the coil, which is probably what I would do next time, is send it off for phenolic coating before you put it in, and the client or the manufacturer needs to pay for that. That's not your responsibility.
I also have customers that were changing the Lennox coil every year. And they said, stop, no more Lennox, put in a carrier.
Yeah.
I will change the coil since.
And what's different about the Lennox coils? Are they all aluminum? Are they tin plated? Are they?
Aluminum.
They're aluminum?
Copper, half aluminum, half copper. Everything that Lennox gets, every year.
Have you tried coils made out of wood?
Or steel.
Could be.
Plastic.
Yeah.
That's our color, zero color. Yeah. Never change a coil until you put a carrier.
Yeah, but that's not that old. I changed the Lennox twice.
Listen, every Lennox coil has changed, and equipment. Coil and equipment. I've changed.
I changed two there.
I changed two.
All right. I think you guys need to mud wrestle over it.
How much you change, Kim? How much you change?
Change what?
Zero color.
At least 2.
Okay.
I changed one year.
That's full system.
I changed one year.
I know.
Hey, everybody's strategy. We need a quote when you put them in, because I think that, like I said, it's a broad problem. But even places that bring in pressure, we still have this problem. Places that aren't really high VOCs, we still have leaks, right? So I don't know what I think it is. The long run times, a lot of growth, a lot of moisture. Growth is doing something. You know, it's byproduct of it is.
I mean, and again, this is where, okay, so if I were you, if I were in your market and you're running into this, we don't have, in Central Florida, so South Florida has more of what you're describing. In Central Florida, we don't have as much. It could actually be some interaction with the salt air too. Like, there's a lot of weird chemical reactions that occur when you have different things in the air. So what I would suggest, even bromine possibly, like bromine could be part of the interaction. There's a lot of things that could be going on there. What I would suggest doing is have some sort of coil treatment. Have you guys tried pulling coils before you put units in and pre-treating them?
So we're trying to get us there. We're trying everything, every single year.
You have tried it before?
We've tried it.
It doesn't work?
We've mainly treated the outdoor.
Okay, go ahead.
C-coat, I think we used to use C-coat
C-coat?
to spray the coils.
And have you tried it on EVAPs as well?
Yeah, you got something, right?
So you could either do it, I mean, I don't know that I would use C-coat though. I might look at something that's a little bit more hefty. Go ahead, Matt.
So, yeah, like, kind of back to what Bryan was saying, like what's different about the situation. Two places that I've run into where we've had where it's like the coils are going out within 6 months or a year, and you can kind of, and you walk in and it's got that smell. A lot of times it's like guest houses, or one lady had like an outdoor kitchen that was completely like hermetically sealed. Like they're like, oh yeah, we have parties out there. I don't think they'd ever had a party out there, and it's right over like the kitchen sink, so that you're getting like maybe some fumes. So like spaces that don't get used a lot too, you know, like where you're not getting any. So maybe like you've got a guest house where it's like nobody's ever in there, and it's above a garage, or might be getting some chemicals. So it's like
Exactly.
And here, it's really the customers that usually they have the really nice houses. They're really tightly sealed. Have a lot of problems.
Right.
Right, because those are the ones who have the highest VOCs. And they maybe they don't, like just like I said, they don't use the house a lot. They're always away. Doors, you know, don't get open as much as most places.
So here's the other thing about VOCs is that they concentrate when you have new materials. So like that's just as like a thing. Like they found one of the correlations that they haven't quite established causation is like babies who their parents are like wealthy and put them into like new cribs with new mattresses and new paint, and they have a much higher like asthma and autism and all kinds of things versus people who are like used, and like I have 10 kids and my kids, like none of them have anything wrong with them. Like it's all hand-me-downs, they play in the dirt, they eat poop, you know, it's just all that kind of stuff. That's a whole nother issue. So I think there is a lot of times, and because we see the same thing, wealthy people where they don't use the space, but a lot of times it's a lot of new materials went in all at once, and then it stayed sealed. Like you packed those chemicals in. So one of the strategies that some people have deployed is doing like really active ventilation for a period of time. So one of the things, yeah, basically you're just flushing it. So you're pumping a bunch of fresh air through it, maybe through a dehumidifier even, and you're just really like kind of working it out. Some people have expressed that has helped. Dustin Cole has talked about that quite a bit, that he uses that strategy. So like even because he does some new construction, and when he's doing new construction, he controls the humidity all through new construction. So that way moisture doesn't, he's in Louisiana, where it's also very, very humid. So it doesn't get in the first place, you know? But again, in terms of a strategy, we were talking about some of this stuff earlier, where when you deploy things that are in the customer's best interest, but it's a competitive market, you can offer things like, hey, this time we're gonna do this coil coating, it's gonna cost this much more, and then we'll warranty it, or that kind of thing. Like I would encourage that sort of thinking, but ultimately the clients do need, like, you know how this gets. Like as soon as you take responsibility for it once, they expect you to own it forever. So you have to always be careful about and that's why I'm encouraging all of you, like, be careful what you take responsibility for. Be careful what you tell somebody you can solve. Because sometimes if it's something new like this, where you're kind of evolving your solution. We were talking about the voltage monitoring, you know, when you're trying to deal with over voltage. What's the name of the Rector Seal? The VRM kits, right? Like, I think it's a really good idea. But again, just be careful what you're promising, right? Because you don't always know what the results are going to be. And a lot of it has to do with just how you talk to the client. You know the VRM's not going to hurt anything, right? It's not going to hurt to do that. And so when you say, hey, this is what this does, but you know how guys talk sometimes, right? And it's important that you don't talk that way. And instead, you're not being ambiguous, you're being confident. This is what it does. And these are the results that we expect. But we're gonna have to see to some degree, right? You're never gonna know unless you build that into your business model. And that's an important conversation to always be having. Indoor air quality is the one that I'm always very careful about. I don't have a problem with people selling indoor air quality products. They do a lot of good things to some degree, but over-promising is where that's where I really encourage people to watch out. Don't say it does things that you don't know it does.
As a rule, say it helps. Usually you say it helps with this product.
Right.
Not that you'll never have a product. You put in a PCO MX4 and it'll never have anything, and no growth, nothing.
Right. Yeah, for sure.
Put it those anyway, but helps is a good thing, because usually most things you do will help to some degree, which is not.
Hurricane stuff. You'll never have a hurricane again.
Right. It keeps the hurricane strapped out at sea.
Yeah.
All right. Another thing that I want to mention quickly about oversizing and short cycling, that's a really big problem that a lot of people don't think about. When a system short cycles, it never really has a chance to get cold enough on the coil. So when we talk about long run time, it really is very important that system runs long run times, because if the system shuts off it's going to take it 5+ minutes again for that coil to get to dew point and start building up moisture again. So systems that are short cycling is a really big problem. You may have a system where it gets a cold coil, but if it's on and off, and that's where a lot of times client education is big on that front, right? Well, I don't want, my old unit ran all the time. I don't want it to do that. It's like, well, hold on, running all the time is a good thing. And not just because it's an inverter system. In your market, you want systems to run all the time if they can, right? Now again, for people who are willing to accept, like, hey, it's 80 degrees in my house sometimes, I like having my doors and windows open, that's how I want to live my life. That's fine, right? And it's going to be helpful if they don't set it too low. The worst kind of person is who has the doors and windows open and then they seal it up and set it to 68. That's the person who's going to reign in their house. Go ahead.
Okay, in the Cayman market, the customer blame the AC for everlasting.
Oh yeah, that's just the Cayman market. Yeah, that's nowhere else. That's a joke. I learned this technique from Alex Meany, who's one of the best teachers, one of the best communicators I've ever met. He used to be the trainer for RightSoft for years. And the technique he does when he's dealing with somebody who's combative is he'll say, yeah, you're right. And then he'll completely oppose what they just said, right? So like, for example, client says, it's a funny technique, but watch how it works if you try it. Client says, man, this thing's running all the time. The old one never used to do that. Oh no, you're right. But it's actually a really good thing when they run all the time because it actually pulls a lot more humidity. That's how we design it. That's actually how you're supposed to design it, believe it or not. A lot of times in older units, they didn't always design them that way, but nowadays it's actually really important that we do that. But you're right. It does run all the time now, right? Go ahead.
Really quick, so we used to have a guy that was a fan of putting the air handlers a full ton smaller than the condenser. Think of any advantages to that?
Well, again, you would only do that if the design allowed for it. So if the manufacturer had a rated match. I would never tell anybody to put in an unrated match for that. That can cause all kinds of problems. But if it is a rated match, then okay. It doesn't sound like it was, though. Generally speaking, that's not the case.
Look at it, don't you? How they used to sell it to us like that because it wouldn't be rated for. If you look at the sensible heat ratio, when you match the equipment, it makes it worse for dehumidification. So you never want to put a small coil, right?
Right.
And a big outdoor unit. Right. Some places it'll work.
Right.
Right. But it's not.
Coil size is a big deal. So when you think about, remember how we talked about filters? Bigger filters are better, right? Like what Matt was showing. Like, it's true because when you have a bigger filter, the air moving over that filter moves slower, right? Bigger filter, air moves slower, right? Slower air moving over the filter, common sense, catches more of the stuff out of the air. Even if you have a mervate here and a mervate there, small mervate, big mervate, which mervate catches more? Big mervate, because the air's moving slower over the bigger filter, right? Pretty simple. That's even better when you do a big, thick 4-inch filter or 5-inch filter. That's even better, right? But the same thing is true of an evaporator coil. If you have an evaporator coil that's really small and you're moving the same airflow over it, or even similar airflow, what's happening to the speed of the air moving over it? It's moving faster, right? And so you get what's called a higher bypass factor. When you have a faster phase velocity over an evaporator coil, less of that air is actually dwelling on the surface of the coil. So it may be that the coil temperature is the same and the air is moving the same speed. I mean, that math probably doesn't work out exactly right, but you're not going to get the dehumidification that you're looking for because the dwell time on the coil is not as long, right? You want the air to be moving. A larger coil is not a bad thing. Just get your airflow right. We want that. We want those bigger coils. I would not suggest, again, to answer your question specifically, I never want anybody to do anything that's not a rated match and look at what the rating sensible heat ratio is, sensible and latent capacity is. In your market, for those of you who are designing, you want SHRs, sensible heat ratios that are lower. That means that of the fraction of one that is sensible heat, you want less of that and you want more latent because less sensible heat ratio means greater latent heat ratio. So when you're looking at charts and doing expanded performance data and picking equipment, which is among the most important things that you can do in sales, pick things with a low SHR. Pretty simple. Because manufacturers do a good job of testing. Like, they just often don't test in a wide enough range of conditions.
Do you find that in the product data of the equipment, or where do you find that?
Yeah, so again, different manufacturers will put it different places. Engineering data, product data, depends. But yeah, you want to go look at that exact match and you want to go across and find that sensible heat ratio. And again, good, yeah, great. And Matt's actually probably better at that because Matt actually does his own designs. I don't, I mean, I talk about it, but I don't, I've got people. Yeah, so final things that I want to mention. When you set up your equipment, long run times, cold evaporator coils. When you're looking at moisture problems, think about, why is this sweating? It's sweating because the air around it is high dew point and the surface is too cold. So I either warm up the surface or I reduce the dew point, hopefully both. And when you are addressing problems with moisture in a home, try to address as many as you can at once. Try to find all of them at once, because then you're much more likely to nail it the first time. You know, cans, seal around ducts, look at the attic, all that stuff. Pay attention to all of that at once. Duct leakage, all the stuff that we've addressed. Go through all of that. And I'm going to try to come up with a special checklist just for you guys, because that would probably be a good thing for us as well. Like of just all the things that you want to pay attention to when you have a moisture issue in a structure, both on the design side, but also on the service side.
Thanks for watching. If you're willing, give this video a thumbs up and drop us a comment. Don't forget to hit that bell icon to stay updated with all of our future videos. And as a quick reminder, HVAC School isn't just a YouTube channel. Dive deeper with us at our main website, hvacrschool.com. Curious for more knowledge on the go? We've got you covered. Tune into the HVAC School podcast, available on all your favorite podcast apps. And while you're at it, join our thriving Facebook group. Also, don't miss out on our free mobile applications available for both iPhone and Android. We're all about community, for techs, by techs.